Good afternoon. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to do is give you a sequel to the first video. Now, the first video, I gave you information on the laboratory reports based off of a moisture content test. And on those reports, it showed you the results. Now, I'm going to do for you an actual moisture test. Now, you see I'm a little sweaty. I've already done 7 of them. But this one is for the video. So I'm going to show you the procedures that I would do in the lab. Now, first of all, some of the equipment that we'll be using. And I'll show you that. This is a spoon. Now this right here, for everybody who doesn't know what this is your number 4 sieve. Now, let me show you how this sieve works. I'm gonna put the camera up, and what I'm gonna do is I'm gonna go ahead and get some soil. Here's some soil, and I'm putting it in the sieve. Now, what you do with this soil, you actually shake it, and what you're doing, you're seeing how much soil passes through a sieve. This is a number 4 sieve. So what I'm going to do, I'm going to go ahead and fill it again to show you how it's done. This is what you do as part of gradation in the lab. Okay, here's the soil. All right, now what I'm going to do, I'm going to shake it. And you've seen a lot of the fine material pass through. Now here's the stone material. But that's what you do with a sieve. This is a sieve. And if you want to know what it is, it's a number 4 sieve. And it has it right on the front. Number 4 sieve. 4.75 millimeters. That's what you do with the sieve. Now, some of the other items that I'm going to use besides the spoon, I'm going to use, we call it a pan or tare. We also have a propane tank. We have a burner. Most of us use these burners for camping. We have a scale and we have a lighter. Now, first of all, first thing we're going to do is we're going to go back to our charts. And we need a certain amount. Now, I've already done a few of these, but I'm going to go right in its entirety and do another one of these sheets for you. Okay, just bear with me. I'll scratch out these zeros. All right, now, when you fill out these sheets, this is an actual test. I'm going to give you the date, which the date is 11/4/23, and it's sunny outside. And I'm going to make up a station. I'd say this is test number 1. Station, I'll just put it out here on Route 32 as 458 plus 00 right, which I'm going eastbound on 32. That's the date. You got to fill that out. All right, testing material. I'm going to put it's number 53 stone or aggregate. So you got that first part filled out. Now, something else that I'm going to do. I'm going to go ahead. I'm going to take this tare or pan and weigh it on this scale. Now, if you see, I got a weight on the scale of 0.76. That's pounds. 0.76. That's pounds. And I'm going to put that weighted pan right here. 0.76. Now, you look at it, we got our information filled out on the sheet. We got the station and everything. Now, since I'm doing this for video purposes, we have to find out what the aggregate looks like. So I'm going to show you. This is the number 53 stone that I'm going to use for this video. Now, since we've taken all the tests, I'm going to use some new material. So I'm going to get it out of here. This is the number 53, and I actually gathered this up in the field. This is real material. Gathered it up in the field. Just trying to get it out here. Not much left of it. I went and got 16 pounds of this stone out. And this is what the aggregate looks like as I put it in the bowl. Now again, we're supposed to come up with a certain optimal, well, moisture is optimal, but generally, depending on which method you use, whether it's ASTM or AASHTO method, you have to come up with a certain factor, certain number. I'm just going to go ahead and take some of this right off the counter here. I like a clean lab, but this is going to use the last of this stone here. This is the actual sample. Get you a good bag sample. And again, this is for video viewing. So, all right, I have the stone. So I'm going to take it over here, add a little moisture to it because we're doing a moisture test. So I'm at the sink here, add a little moisture. Don't want to add it too much. Don't want to make it too wet. All right. So what I've done is I added a little moisture. So what I'm doing is I'm basically stirring it. Stir it like you are cooking soup. Get it a little saturated, but not overly wet. But I want to get it saturated. And this is generally what they do in the lab, especially if you have proctors. And make sure that everything gets covered equally. And once I have what I need, mix it all around. Now you want to make sure that you get everything. Everything. You don't want to lose your sample, so since I'm holding the camera in one hand, I'm shaking a little bit of it off in the other hand. All right. Now, what I'm going to do with this sample, I'm going to weigh it. I'm going to weigh it. This is the wet sample. So I'll go back to the scale. I'll weigh it. I got 1.92. That's pounds. So I'm going to record that number. 1.92 pounds. So the next thing I'm going to do is I'm going to turn on my burner. Take this lighter. Okay. I got my fire lit. And now I got the sample on the burner. Now what I'm going to do while it's on the burner, I'm going to turn it up a little bit. And the whole purpose for doing this experiment is to cook out the moisture. Because what I'm trying to do is obtain a moisture. Now you've already seen the stone. It's aggregate. It's number 53. This is what we use out here. Now at PennDOT, when I worked there, we called it GAB, graded aggregate base. Now what I'm doing, I'm stirring it, and I want to make sure I get all the moisture out, and I want to make sure there's nothing left on the spoon. See, there's a little bit left on the spoon, so what I'm going to do is get it off. Use my fingers. And then I'm going to continue to stir it. Now there are other ways you can also get the moisture out of any type of aggregate. You can use an oven. You can use a burner. You can even do this experiment in your own house. So what I'm doing, you know it's still wet. Now, you got to be careful when you're cooking this, because you can cook the material and it can get very, very hot and burn. You don't want it to burn. This is why you want to pay attention to it. Now, a number of us were inspecting. We have to take a sample, we have to do it outside. Now this is more of a laboratory experiment, and for any of you that's interested in going into geotechnical engineering, this is the same thing you would do for soil. Now as you see it cooking, you see the color changing. Well, it's not really the color changing, it's the moisture that's being cooked out of the sample. Now again, what I'm doing, just gonna let it sit. It's cooking. You notice the stove, you can cook soil. You have stoves that even cook bituminous concrete. And what they do with bituminous concrete, they burn the tar material off and you get down the stone. Now what I'm doing is stirring. And the reason why I'm stirring, now you see that stone in there? It's still a little bit, it's got moisture in it. You want to get all of the moisture out of the material. I'm going to continue to stir until all of the moisture is out of the material. Again, you don't want your material to burn. So now, you see the spoon? You can see it start turning to dust. Now, let me turn the fire down a little bit. You want to turn it down a little bit. And this experiment doesn't take a long time to do. But you want to make sure everything is cooked out. Now looking at it, even when you stir it up, you still want to take everything out. Now, I'm going to go over here and get the glove. This pan is extremely hot, so you don't want to touch a hot pan. So I'm going to take the pan off. Now, what you can do, I got to turn the fire. Got to make sure the fire is turned off too. So, what I'm doing, I'm stirring. Just to make sure we get all the remnants off. And see, when I see dust going up in the air, that means that you have a lot of moisture that's being cooked out. Again, this is aggregate. We still got a little bit of some left. And again, what I'm doing, I'm stirring everything off the bottom, because even when you stir it, it's still hot, still got enough heat to take some of the moisture out. Now you can see the dust on the spoon. Okay, now what I'm going to do, I'm going to get my glove. I'm going to take the material. See, the first material was wet material. So I weighed the wet material plus the pan. Now this one is the dry material plus the pan. So I go ahead and I read what my weight is for the dry sample. I got 1.86. So I go over to my sheet and I write 1.86. So now you can see the sheet. You got 1.86. What I have here, I have my weight of wet material, which was 1.92 after I weighed it. And then I weighed it again after I cooked all of the moisture out, and I got 1.86. But before I did anything, I weighed my tare or my pan, and I got 0.76. So now I have some other math to do. So what I want to do is I got to look at the information here. All right, now what I want to find is the weight of moisture. So what I'm going to do is I'm going to take the weight of pan plus my wet material, and I'm going to subtract my pan of dry material. And once I do that, I come up with 0.06. Still not done though. Still not done at all. The next thing I'm going to do is I'm going to take, and let me get some paper here. I'm going to take number 5, which is my weight of dry material. So I'm going to subtract 0.76 from 1.86. Again, I'm going to subtract my pan from the weight of my dry material. So what I'm going to have here is 1.86 minus 0.76, and I come up with 1.10. So my weight of dry material is going to be 1.10, and that's in pounds. And there it is for you. Now, I'm still not finished. because there's still something I need to do. I need to find out what my percent of moisture is. So what I'm going to do is take my weight of moisture, which is 0.06, and I'm going to divide it by 1.10. So in other words, I'm going to take 600ths and divide it by 1 over 100, which or 1 plus or 1.1 over 100. So basically, I went my calculator here. So basically, we're going to have right around 5% moisture. So again, I'm going to take 0.06 and divide it by 1.10. Now there are different ways you can do that. Take 1.10 and divide it into 0.06. And of course, when you do the math, you have 0, 0, brings 6, 0.0, 0, and this is bring down 6, and we have a moisture right around I'd say 5.9 and 6. That's what we have. Just gonna call it 5.9 or 6. But that's how you do everything. And if I go to my sheet, what do I need for optimum moisture? I need between, here are the numbers, 6.3, I need 4.9 and 6.3. And where does 5.9 fall? Right in the middle of everything. But what you've seen is how to calculate a moisture. And to review everything, you go and weigh all the information out. And once you weigh it all out, you can go ahead and do what you need to do. And what you need to do is once you weigh everything, that's when you do the math. And you have to do the math. You have to do the math. That's basically how you do everything. And 5.9 or 0.06, I got 5.9 points, or let's just round it up to 6, because that's what I got. 6%. 6% is the optimum moisture. And that's what you got here. Even without a calculator, you just go ahead and take the numbers and flip them up, flip them down. You know the rules of mathematics. But overall, that's how you calculate a moisture. And then after that, just take everything, you clean it on up. And you situate everything. But that's what we do in the field. It's very important that we do moistures. And I'm going to show you some that I've already completed. Here are all the moistures that I've already completed. test 3. That's test 4. This is test 2. And that's test 1. But when you do a moisture, make sure you run more than one test. And of course, here's some other ones that I've done too. Always want to check the consistency of your numbers. But that's how you do a moisture. And that concludes this segment on a moisture content test. If you like what I just presented, please comment, share, and subscribe. And if you are looking for some political and some social content, you check out the 411 Talk Zone Radio Show on YouTube. Now, if you can't find the 411 Talk Zone Radio Show on YouTube or the QCIS channel on YouTube, you can check both of those channels out on Twitter. Now, for the QCIS channel, I'll take it one step further. Since the QCIS channel is an educational channel, you can also find that channel on my LinkedIn page. And once again, thank you for viewing this content from the QCIS channel. We're on this channel. You get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening. And I'll see you next time.